Welcome once again to my tiny bench. Today we have this Pioneer SA-6700 integrated amp from the mid to late 70s, and this was a purchase off of eBay. Don't know too much about it. The description simply said power's on. I'm a little reluctant to turn it on at this point. Mostly it just looks kind of, I guess dirty is the best way to put it. I'll spin it around and take a look at the back. So here's the back of the unit. Not sure how much can be detected from the camera, but it's got a little bit of rust on it, a little corrosion. I'm not sure if it's going to clean up or if some of the rust is permanent. But feels like a nice solid amp otherwise. Wood sides, wood top. I think next step, I'm not going to try and plug it in quite yet. We'll pop the top and take a look of an overhead view. Thanks. Here's a quick look at the inside of the unit. See, there's some spider webs. And it's covered in dust, dirt. I suspect it was used in a garage, but other than that, I don't see any signs that this unit's ever been worked on. That's great. We can clean up dirt. I don't see any bulging caps or anything that's clearly blown or leaking. Some nice Elna 8000s. I believe this is a plus 40 and a minus 40 DC rail. Yeah, near as I can tell, it's all original. Maybe one of those situations where kid went off to college, parents used the room for something else, threw it in the garage, and it sat there for a while. I think next we might clean out the interior and then bring it up on a Variac, the dim bulb, see how she does. If it hasn't been played for a while, these caps are going to want to at least reform and probably be replaced. Let's see, these are the outputs. Those look to be original. Back in a bit. Just going to do a brief handheld to show the dirt on the face. Not quite sure if that's overspray from some unrelated cleaning effort, like soap from the hose end, but it is kind of dirty. Another handheld segment. Sorry about the lack of stability on the camera, but I wanted to show how corroded these RCA jacks are to start with. I'll show an after later, but just kind of want to capture that. Another thing that we had looked at earlier and I wanted to show again were these RCA plugs. They're not perfect yet, and I'll take another swing at it, but I just wanted to show a little metal polish, microfiber, 9mm socket, some kind of a handle. put the microfiber in there, put the metal polish on it, and then just rotate it back and forth. That's a good tip that we got from Prime Hi-Fi, an excellent restorer. Well worth watching his videos. Really good stuff. More in a bit. Okay, we're back with this mid to late 70s Pioneer SA-6700 integrated amp. What we've done so far, we tried to clean up inside using a brush and a vacuum cleaner. I think we've made pretty good improvement. We did rescue one bug who made the journey from Minnesota, I think. Welcome to Florida, bug. I rescued him, put him outside. Terribly windy day today, but he seemed pretty happy to be outside. Also serviced the pots and switches, cleaned them with Electrosolve, and then lubricated them with Deoxit F5. I also did the same thing for the RCA inputs and for the speaker outs. Cleaned and verified no breaks or tears or exposed wires on the power cord. I've yet to plug it in. Do have a little bit of the standing solvent from the Electrosolve or perhaps the D5. I'm going to give that a little while to evaporate and work itself out before I turn it on. And like I said earlier, when we do bring it up, we'll bring it up with Variac and a dim bulb tester. I also went around with tweezers and made sure I didn't have any of the resistors which are extended up off the board, presumably for heat dissipation reasons, but some of them were laying down, so I lifted them up so I wouldn't have a likelihood of leads touching leads and shorting something out. Like I say, next I will just let her dry a bit. Always more comfortable to leave it for a little while, and then we'll come back and we'll do a quick test, and we'll report the findings then. I thought I would show the schematic review and troubleshooting technique for this Pioneer SA-6700 that we have currently on my tiny bench. Recall that I started troubleshooting because I was missing the plus 40 volts from the T2 side of the circuit. The way this amplifier works, there are two separate transformers, not just windings off a transformer, but two separate transformers, one that's called T1, one that's called T2. T1 is involved primarily in the power transistor output section and the somewhat rudimentary protection circuit that the amp uses, and T2 provides power to all of the other rails. As I was troubleshooting, it looked like I had nothing at the emitter of Q17, but I thought I had about 40 volts at the base. In hindsight, I think I was wrong on that, but that's what I thought at the time. So I pulled Q17 and tested it out of circuit, and it tested fine on the inexpensive all-component tester that we all use. And I checked all these surrounding components. They were all good. Pulled Q18, and it also tested fine. So I put them back in circuit, and I brought the unit back up, and oddly, all of a sudden, the dim bulb tester started glowing brightly, so I powered it down. did a visual inspection, and there was nothing noticed, but obviously with that dim bulb glowing, I knew I had a short somewhere. And I had to figure out a way to isolate between this section, these power rails, and these power rails. So I went ahead and I pulled these diodes, and I pulled this cap. Would have been an easier way to do it, but that's what I wanted to do. I brought the power back up on a variac slowly, and there was no glow. So that told me most likely my problem is not with the T1 circuitry, but with the T1 circuitry. I drained these filter caps and checked various resistance. When I was measuring from these caps to ground, the resistance was substantially higher than I was expecting. Now this R121, R122, those are 22K resistors, so I know even if we disregard everything parallel downstream, I've got at worst 22K path to ground. And it was, the actual measurement was substantially higher, so I checked directly across these resistors, pulled them out of circuit. Sure enough, they were blown wide open. But no signs of trauma. I pulled them out of circuit, put new ones in, and I pulled out the heat sink with the power transistors attached. I realized later that I should have done that much earlier. I had verified previously that they weren't shorted, but these are those bat wing transistors, and I believe they're originals, so I certainly didn't want anything to happen to them. So having replaced these and determined that these were blown, I put the rectifiers back in, but I left those power transistors out. I put voltmeters all around all the various rails. So I was reading here, was reading here, was reading here, was reading here. Just wanted to get a clear picture as I powered it back up. And I brought it up slowly on the variac, and the bulb on the dim bulb tester glowed again. I kept the variac pretty low though, only about 20 volts. And I noticed that I had no voltage on the T1 plus 40 rail, which is this bottom leg of the bridge. But oddly, I did notice this time I had voltage on Q17's emitter. Certainly it was well below the 40 because remember I've got my variac only supplying 20. So I thought maybe this T2 circuitry might be okay. Now the T1 circuit has very limited duty, like I mentioned earlier. It provides the power rails for the output transistors and this protection circuit. Now this particular amp does not use a power on relay or speaker protect relay, but rather what it does, it has these two transistors which are sensing the DC going to the speaker outputs. If this DC is substantially plus or substantially minus, one or the other of these will turn on. When it turns on, it sends voltage energizing this triac. This triac then is allowed to conduct to ground. So the plus 40 feeds through these very small 0.5 ohm resistors through the triac directly to ground. And what then is supposed to happen in order to protect the circuit is the main fuse will blow. And that's the extent of the protection circuit. So T1's role in this amp is to provide power to the power transistors and to provide a path for this plus 40 to get to ground in order to pop that fuse in the event that these transistors detect DC on the speaker outputs, and they'll trigger the triac. I had checked at this location for DC to see if these were powering on, and it was really very minimal, was next to nothing. So I suspected that D26, this triac, might be shorted. And sure enough, it was. It tested short in circuit. I pulled it, tested short out of circuit. So I replaced it, and then I turned back to bringing up the unit slowly on the variac. And once again, I watched various rails. What I like to do is I like to clip on the rails with 4 or 5 voltmeters at the same time, rather than popping around with the probe. Just in case something's out of whack, I can see it quickly and power it down. So as I'm watching the rails, I started ramping up slowly with the variac. I noticed now I've got voltage on the T1 40 volt line, which is ramping up as my variac is ramping up. So sure enough, that triac was the issue with that rail. And I don't know what caused it to short, if there was some event, but it may have just been old and worn out. I also noticed that I had voltage here on the T2 40 volt rail. My dim bulb tester was not glowing. So for a few moments, I thought all of my power supply issues were resolved. So I continued to ramp up my voltage on the variac, and everything looking like smooth sailing. And then all of a sudden, here comes the twist. When the AC on my variac reached about 40, the voltage here on the emitter of Q17 had been ramping up. It reached about 12 volts DC, but when the variac hit about 40, voltage here fell to just about 0. I thought that maybe Q17 was breaking down under the voltage, or perhaps something downstream was causing a draw substantial current draw when it reached a certain voltage. I needed to rule out Q17 being the problem, so I subbed in a small signal NPN that I had on hand. No, it certainly wasn't sufficient to serve as a replacement, but it was good enough to determine if an NPN there would recreate the symptom or cure the symptom. I ramped back up with my variac, and now I'm past 40 volts on it, and all of my voltages look like they're coming up as the variac comes up. But when I got to 50 volts this time, I thought my original transistor must have been the difference. I'm 10 volts higher on my variac. Well, that was a little premature, because as I got to about 52 volts on the variac, this emitter of voltage again crashed to 0. There's something that was loading down that rail after a certain threshold was reached, or so I thought. I studied the downstream circuit, and this 40 volts leads to a lot of different areas, feeds a lot of sub-circuits. And I wasn't quite sure what would be the easiest way to isolate. So I gave it some thought, and I thought maybe it could be something else. So instead of trying to isolate these various circuits, I just put voltmeters on the 3 legs of Q17, and I started ramping up. And as I got to that magic moment where the emitter shot to 0, I noticed that the base of Q17 was also 0. I then turned to this Q18 and studied that circuit a bit. I pulled it and tested it earlier and it was good, but I never really monitored it operating. So I put voltmeters on its 3 legs and ramped up the variac. Now here's how this circuit is supposed to work, which I didn't quite understand at the time. When power comes on, plus DC feeds through D18, this diode here, and it feeds positive voltage through the base of Q17, Q18, which turns Q18 on. When Q18 is turned on, it provides easy path for Q17 to turn on. Turn off. Q18 turns on, it provides this easy path to ground through these relatively small resistors, turning Q17 off. Q17 is turned off, it means there's no plus 40, therefore none of these associated circuitries are energized. Meanwhile, the DC, negative DC, feeding through D19 is delayed by this RC network that you see along this path here. After about a second, this negative DC should be done being delayed, and it should hit the base of Q18, which would turn Q18 off, allowing the plus voltage to, instead of feeding to ground, hit the base of Q17, turning Q17 on, allowing the plus 40 to feed to all of the preamp circuits. Now, as I said, I was ramping up the variac and I'm monitoring the 3 legs of Q18. And no matter what I'm doing, the voltages were never going negative. They were always staying slightly positive. I then watched the base of Q18 and the emitter of Q17 at the same time. And finally, it occurred to me. At the moment the base voltage of Q18, as I was ramping it up, rose above 0.6 volts, the emitter voltage of Q17 crashed to near 0. And previously, when I had applied full power, Q18 was on immediately and it never turned off. So I didn't see the connection between these two clearly. However, when I ramped up the voltage with the variac, Q18 did not turn on immediately because the positive voltage on the base was below 0.6 volts and it just didn't turn on. It was below the threshold. By watching these two at the same time, the connection was clear. Since Q18 was never getting a negative voltage, I started searching for a faulty component in that delay circuit that we'd pointed out. All the resistors were fine, diodes seemed fine. I looked at C69, and I looked at C72. I use a peak ESR capacitor meter like a lot of people do. And C69 is supposed to be a 10 microfarad capacitor. It showed 1,600 microfarads. C72 was also out of spec. It's supposed to be 33 and it measured about 50. Certainly not as bad, but That's a substantial difference when we're talking about a timing circuit. So I replaced both of those capacitors. And again, I started ramping up. And lo and behold, this circuit worked as it was supposed to. I double-checked all my rails, all voltages were present. I then verified that the bias was within spec, there was no significant DC on the speaker terminals, and finally hooked up speakers, put a signal through the amp. And some days, there is no sweeter sound than that 1K test signal finally playing through the amp that you just fixed. Thank you. Be back soon. We are back on the Pioneer SA-6700. You see we got clipping at about 21 volts. And while we're clipping, we have total harmonic distortion of just under 0.03. Now we're going to look at the other channel. And I think we have clipping there, just under, yep, just under 20 volts, 19.